Good day! Welcome in today's episode of DepEd TV. I am Sir Jayson Flores, also your math buddy, and I will be here to help you in developing your logical reasoning and critical thinking skills. Is your self-learning module ready? What about your pen and paper? Great! Let's begin a fun and exciting lesson. For this lesson, you are expected to determine a geometric sequence, identify the common ratio of a geometric sequence, find the missing term of a geometric sequence, determine whether a sequence is geometric or arithmetic, and explain inductively the difference between arithmetic sequence and geometric sequence using real-life situations. Arithmetic sequences were presented to you in the previous episodes using real-life situations. In this episode, we will determine a geometric sequence and differentiate it from an arithmetic sequence. Have you ever wondered how plants grow? In your Facebook account, how would you know how many likers or reactors will you have in a couple of minutes if a certain pattern is observed? When saving your money in the bank, have you realized how much will it increase monthly, quarterly, or yearly? These are just but situations that will help you arrange or organize things accurately and make wise decisions. Well, let's take the challenge by answering the first problem. You are planning to buy a new blouse which costs 300 pesos as a present to your mother this Christmas season. You started saving money on the first week of November and doubled the amount to be saved every week. If you started saving 5 pesos on the first week, will you be able to buy the blouse at the end of the second week of December? To solve the problem, you must have to analyze accurately the given situation. To help us understand the problem easier, let's present the given in tabular form. There are 6 weeks from the first week of November up to the second week of December. The initial amount saved is 5 pesos, while your target amount at the end of the second week of December is 300 pesos. The amount to be saved is doubled every week. Since we started with 5 pesos for the first week, for the second week, you have to save 2 times 5 pesos. So that's 10 pesos for the second week. From 10 pesos, how much you should save for the third week? Yes, that's right. That's 10 times 2 will give you 20 pesos for the third week. How about on the fourth week? Yes, that's 20 times 2 will give you 40 pesos for the fourth week. How about on the fifth week? Yes, that's 40 times 2 will give you 80 pesos for the fifth week. How about on the sixth week? How much will you save? Try it yourself. I'll give you 5 seconds. Well, on the sixth week, you should save, that's right, 160 pesos. After 6 weeks, how much will you save all in all? That's right, you will have 315 pesos after 6 weeks. From that amount, can you buy that blouse as a Christmas present to your mom? Yes, you can. Absolutely. What is the sequence obtained? We have the sequence 5, 10, 20, 40, 80, and 160. Can you see any pattern from this sequence? Yes, that's right. Considering 5 pesos as the first term, the second term, 10, can be obtained by multiplying the first term 5 to a constant number 2. By multiplying the constant number 2 to the second term 10, you will get the third term 20 and so on. The constant number being multiplied to the terms to get the next term is referred to as the common ratio, represented by the letter R. Again, the constant number being multiplied to the terms to get the next term is referred to as the common ratio, represented with the letter R. This sequence is an example of geometric sequence. Using the given terms of the sequence, how will you obtain the common ratio? The common ratio R is obtained by dividing the succeeding term by the preceding term. Again, the common ratio R is obtained by dividing the succeeding term by the preceding term. Or simply using this formula, a sub 2 divided by a sub 1, or a sub 3 divided by a sub 2, or a sub 4 divided by a sub 3, and so on. Do you know that by using the common ratio R, we can get the missing terms of the sequence? Let's try this. Identify the value of the missing term that will satisfy the given geometric sequence 3, 12, 48, blank. The missing term is the succeeding term and comes after 48. To obtain the missing term, let's determine first the common ratio, and that is dividing the second term, or a sub 2, by the first term, a sub 1. Let's substitute the values. A sub 2 is equal to, that is 12, divided by a sub 1, which is 3, and 12 divided by 3 will give us 4. Or you can also use a sub 3 divided by a sub 2. Our a sub 3, or the third term, is 48 divided by our a sub 2, or the second term, that is 12. 48 divided by 12 will also give us 4. Therefore, our common ratio R is equal to 4. Now, using the common ratio 4, we will get the next term by multiplying the third term, which is 48, times the common ratio. Our a sub 4 now is equal to a sub 3, which is 48, times the common ratio, which is 4. Our a sub 4 is equal to 192. How about if the first term is missing, just like in this example? Blank, 32, 64, 128. The missing term is a preceding term and comes before 32. What should we do next? Yes, we will determine the common ratio. Again, that is by dividing the succeeding term by its preceding term. Since we don't have the first term, we can resort to dividing the third term, or a sub 3, which is 64, by the second term, or a sub 2, that is equal to 32. Dividing 64 by 32, we will get 2. Or we can use the fourth term, a sub 4, which is equal to 128, divided by our third term, or a sub 3, which is equal to 64. 128 divided by 64 will give us 2. Thus, the common ratio for this sequence is 2. Since we are looking for the unknown preceding term, instead of multiplying, we will divide the second term, 32, by the common ratio 2, which is equal to, correct, that is equal to 16. Thus, our first term, or a sub 1 in the geometric sequence, is 16. Oh, so amazing, isn't it? Remember, to identify the missing term, first, you must have to find the common ratio. If the unknown value is a succeeding term, then multiply the preceding term to the common ratio. If the unknown value is a preceding term, then divide the succeeding term by the common ratio. Let's see what you've learned. Find the common ratio and the missing values in the sequence blank, negative 10, 50, negative 250, blank. As you can notice, we don't have the first term, or a sub 1, and the last term, or a sub 5. First thing we need to do is to look for the common ratio r, and that is using the given values from our sequence. In this case, we will use the third term, a sub 3, divided by the second term, which is negative 10. So that's 50 divided by negative 10, we will get negative 5. We get negative 5 because we divide numbers with unlike signs. To confirm whether we have the same common ratio, we will try the fourth term, a sub 4, divided by the third term, which is a sub 3, that is equal to, a sub 4 is negative 250, divided by the third term, which is 50. Negative 250 divided by 50 will give us negative 5. See? If you use a sub 3 divided by a sub 2 or a sub 4 divided by a sub 3, you will get the same common ratio. Since we now have the common ratio, let's find the first term, and that is by dividing the second term, a sub 2, by the common ratio. A sub 2 is equal to negative 10 divided by the common ratio, which is negative 5. Our a sub 1 now is equal to negative 10 divided by negative 5, that is positive 2. Positive since we are dividing numbers with like signs. And to look for the fifth term, or a sub 5, since we're looking for the next term, we will use multiplication, multiplying the fourth term to the common ratio, which is negative 5. So that's a sub 5 is equal to the product of a sub 4 and the common ratio. A sub 5 is equal to, our fourth term is negative 250 times the common ratio, which is negative 5. Our a sub 5 is equal to 1,250. Positive since we are multiplying numbers with like signs. Thus, the fifth term of the sequence is 1,250, and the missing terms are 2 and 1,250 respectively. From the given sequence, notice that there is a common ratio being multiplied to obtain the succeeding term or terms, or dividing the given succeeding term by the common ratio to get the preceding term. Bear in mind, these concepts will help you determine that a given sequence is a geometric sequence. Take a look at these sequences. For letter A, 12, 15, 18, 21, and so on. B, 5, 15, 45, 135, and so on. Which do you think is a geometric sequence? How about an arithmetic sequence? Notice in sequence A, a number is added to the first term 12 to get the second term 15. Likewise, the same number is added to the second term 15 to get the third term 18, and so on. What is the constant number? Correct, 3. What do you call the constant number 3 in the sequence? Yes, it is called the common difference. Now, let's take a look at sequence B. Notice a number is multiplied to the first term 5 to get the second term 15. And the same number is multiplied to the second term 15 to get the third term 45, and so on. What is the constant number? Yes, it's 3. And what do you call the constant number 3 multiplied to the term to get the succeeding term? Very well. We call it the common ratio. Take a look again to the given sequences. For sequence A, 12, 15, 18, 21, and so on is... You're right! Since a common difference 3 is added to the preceding term to get the next term. Therefore, it is an arithmetic sequence. For sequence B, 5, 15, 45, 135, and so on is what type of sequence? That's right! It is a geometric sequence because a common ratio 3 is multiplied to the preceding term to get the succeeding term. Using the table, determine the pattern and the type of sequence the following belongs. For sequence A, that's 6, 11, 16, 21, and so on. What is the pattern? Yes, that's correct. 5 is added to the preceding term to get the next term. What type of sequence is that? Correct. That is arithmetic sequence. Let's proceed to sequence B. 3, 9, 27, 81, and so on. What is the pattern? That's correct. 3 is multiplied to the preceding term to get the succeeding term. And what type of sequence is that? Correct. That is geometric sequence. Congratulations for a job well done. Now that you've learned the concepts related to geometric sequence, how does arithmetic sequence differ from geometric sequence? Well, an arithmetic sequence is a sequence obtained by adding a common difference, d, to the preceding term in order to obtain the next term or terms. While a geometric sequence is a sequence obtained by multiplying a common ratio, r, to the preceding term in order to obtain the succeeding term or terms. Now, determine if the following sequence is arithmetic or geometric. Number 1, 2, 6, 18, 54, 162, and so on. Number 2, 1, 3, 5, 7, and so on. Number 3, negative 1, 0, 1, 2, 3, and so on. And number 4, 3, 6, 12, 24, and so on. You're right! Items 2 and 3 are arithmetic sequences with the common difference of 2 and 1 respectively. While items 1 and 4 are geometric sequences with a common ratio of 3 and 2 respectively. Oh, so awesome, right? I hope you've learned a lot. And that concludes our lesson for today. See you again in the next episode. And please don't forget to like and subscribe to the DepEd TV official YouTube channel. This has been Sir Jayson Flores also. Bear in mind that learning math will always be fun and easy. Be also, be awesome. Only here on DepEd TV.